Guys, day 2 of 3.14. I heard from many students yesterday that they thought yesterday was really easy. I think you'll think today is easy as well. We're finishing up the polar graphs, 3.14. You'll finish your homework in class and stuff, but this is an interactive lesson. I need you guys to be working with your calculator along with me, not just sitting there letting your classmates answer or me answer for you. So just do me that favor and participate. We are going to have a work day tomorrow and homework check, and I'll introduce the project to you. And remember, the project comes from 3.14, so if you missed, I don't think any of you missed, but if you're watching this video and you missed the day 1, you need to make sure you go back and watch day 1, or you won't be able to do the project, okay? So let's get started with our very first example here is giving us an equation, and I want you to notice that it has an x and a y in it. I'll come back to why it has x and y in it in a moment, but what I want you guys to see is that just like at the beginning of class yesterday, we had x-y charts built for us, and we had to plug and chug. The difference between yesterday and today is that the beginning of yesterday, we did not use our calculator. If you remember, to plug the numbers in, we actually had to use our unit circle knowledge, and we plugged in exact values, and we didn't use our calculator, and we came up with points to graph, and then we graphed it. Same idea today, but we're going to make it a lot quicker. And again, don't overthink that that's an x and y, not an r and a theta. I will tell you why. Just think of it as inputs and outputs. And we're going to just plug right into our graphing calculator. So you must clear your RAM. You must clear it, because if you happen to look at your calculator, it's probably got some crazy looking graph on it, which you guys will be graphing too in a minute. So clear your RAM and just start plugging and chugging. I want to see everybody doing this, and then I'll let you stop and I'll give you the rest of the answer so you don't have to sit here for an hour plugging and chugging, but you're just typing in your calculator 1 plus 2 sine, and then whatever the x value is, and writing your answer. 1 plus 2 sine of pi over 6. And you don't have to close your parentheses if you're going to hit enter. And you get 2. And you're going to get some decimals. And that's okay. I don't care what you round to, because if you think about it, 1 plus 2 sine over 4. If I graph 2.4, 2.41, 2.414, 2.4142, it's not going to look any different. So just quick graph, doesn't have to be, quick decimal, doesn't have to be perfect. Juan, are you doing this? I'm waiting to make sure everybody's doing it before I stop you and give you the rest of the answers. All right, if you get the picture, steal mine. You don't have to sit there and do all that. Just steal mine, guys. Should be writing. Just look up here, write mine down. So here's the point I'm making here. If it was a graphing calculator problem, you could use your graphing calculator, get all these points. There's no work that has to be shown quick, easy. Without a graphing calculator, this method, you'd have to use your unit circle knowledge. It takes a little bit more time, right? You got to think, what is sine of that angle? Plug it in, multiply it by 2, add 1. So you can see plotting points you could really do with a calculator or without a calculator, okay? Now, why is there an x and a y here? Because what we have been graphing with yesterday and today, let me give you a second to finish. We won't cut up to me. What we have been drawing or graphing, what this looked like yesterday was this. Oh, thank you. Instead of x's and y's, we had r's and thetas. Well, what I want you guys to do is to make a connection right here. The way it was printed with the x and the y and the table of values of x and y, that's rectangular. That's going back to, I think it's section 3.5, where we graphed sine. Remember middle up, middle down, middle? You had an amplitude a period, a midline, a phase shift, all that stuff. That's what this is. That is an amplitude of 2, a midline, sorry, that's a D, a midline of 1, and guess what? It's graphed right here. This is your middle up, middle down, middle, with a midline of 1, an amplitude of 2. It's been a while, but that's what that is, right? X and Y. Well, guess what? If I change the X's and Y's to R's and thetas, I would still get these same values, same exact values. It would just say theta here and R here. And guess what that graph would look like? It would look like that. So why are they two different graphs? Because it's two different ways of graphing. Just like we talked about, I'll use that analogy again from Countryside High School to Countryside Mall. The destination is the same. It's just a different way of graphing, all right? I know it looks very different, but this is putting a whole bunch of points together. A whole bunch of rectangular points together made this picture. A whole bunch of polar points put together made this picture. But it really is the same points. Let me prove it to you. At pi over 2, for example, look at pi over 2, we went up 3. Sorry, that's 1, 2, 3. This is 3. And there it is, pi over 2, 3. At angle 0, we went out 1. It's right there, right? 0, 1. At pi, where's pi? Pi, we also went out 1. And so you can find a lot of the points that are here, in here, and a lot of the ones in between that we really didn't need, right? Because the way we learned how to graph this, let me write it again, because I'm going to review that, without making a table of values, was the cutesy, quick way of knowing a few important things. We have a positive sign. That means we go up. Up how many? A plus B. 1 plus 2 is 3. So there's that first point at 3. Then we used our axis width, which is the 1. So to the right 1, left 1. That's how we would have gotten the next 2 points. And then we only needed 1 more point, and we did that by determining what type this is. You do A over B. That is less than 1. Less starts with an L, so does loop. So we had to put our final point somewhere between our first point and the axis, so it went in between right here. How did we get that value of 1? You either do 1 minus 2 or 2 minus 1. It doesn't matter. In both cases, whatever you get is absolute value, and that's how we got 1. So we wouldn't have done all of this necessarily. It's actually quicker to do it with our little tricks. And we'll review this again. Today's homework is going to have the new type I'm about to teach you, and then a mixture of all the ones we did yesterday. So today is a really good homework assignment. You'll finish it in class of all the types of polar function graphs that you need to know. All right, but I just want to make a connection for you between a sine graph, rectangular, middle up, middle down, middle, and on the polar graph looked like this, okay? Let's go, we're actually moving backwards to page 174. I skipped the rose curves yesterday on purpose, all right? Oh, I forgot to show you something else. Don't turn your pages back. Let me show, I forgot, I was going to show you how to put this on your calculator using polar. So go ahead and clear your RAM again. Sorry about that, because you have to know how to do it. This is part of today's lesson, is being able to put these in the graphing calculator. How can I put an R and a theta in here? Well, we have to change the mode, okay? So go to mode. Everybody should be doing this. Everybody has to put their calculator in this mode. So I want to see everybody pick up their calculator so that they're doing this. Everybody's on their calculator? Please and thank you. All right, so you hit mode, and then you're going to go down to, see where it says function? Everybody should have function highlighted. That's like your regular rectangular XY business. You're going to arrow over to polar. Okay? Zach and Juan, I can't see you guys. Are you doing this? Make sure. I just can't see. That's all. So I want to make sure, because if you don't do this, you're not going to be able to do any of the problems. All right, so once you have polar highlighted, you hit enter, and now you're in polar form. It's that simple, okay? If you hit clear, don't worry, you're not clearing that entry, it's entered. Clear brings you back to your home screen, but let's go up to y equals and see if you see what has changed. What has changed? Yeah, it should be an R. That's what we needed. If we didn't change it, it would have said y. There's no y in this equation at all. It's R equals, so let's type it, 1 plus 2 sine. And where is theta? Well, our calculators are really, really smart, and they know that when we switch to polar form, we don't want x there, we want theta. That's why, and you may have wondered it throughout the year, why does it say x comma t comma theta comma n? Because depending on what mode you're in, your calculator will put the right variable in. Since we're in polar mode, when you hit that button that I will keep calling x, it puts theta in. Okay? So now, if you graph it, you'll get that picture. Now, that does look like this, right? These look alike, but here's where I want you guys to take a second and play with your zoom button. There's a zoom that I think is the best for these types of graphs. The zoom I like the best is zoom square, number 5, okay? And the reason is because it changes like your rectangular looking screen, and it changes the dimensions to make it more square. If you notice, it makes it a little bit more round. You can zoom in if you want to. I could hit zoom number 2, and it will zoom in. If I hit enter, it makes it bigger or back to smaller. Another one that some people like is zoom trig. It kind of fills the screen a little bit better without zooming, but you can see how it makes it look like it's elongated, all right? Whatever zoom you use, it won't change your table of values. It just changes the way you're looking at it, okay? It doesn't change the points, it just changes, like, it's think about a camera, zooming in, zooming out, all that different stuff, okay? So it's important to be able to put these in your calculator for what we're doing today. All right, so now let's back to page 174, where you probably already are. So we just did a review of one of those limicons, the loop one. Remember, we had a heart, we had a loop, we had a dimple. And those formulas always have a plus or a minus in between the A and the B. Let's review the other one we learned yesterday, which was circles. Circles are always R equals either a positive or a negative A cosine theta, or a plus or minus A sine theta. They're the most basic graph. There's one number, a sine or a cosine, and a theta. And when we see those, we know it's a circle. If you see the plus or a minus, it's going to be the heart, limicon, or dimple. Our final type is the rose curve, and here are the formulas for that. Notice it's almost identical to the circle. You're going to have an A value, a cosine or a sine, but what's different is that there is an n in the parentheses with the theta, okay? It's a multiple angle. That's the only difference between a circle's equation, and a rose curve. So let's look at those. A and B are rose curves. You can see there's an n value there, and there's an A value always after the equal sign. That goes for every single type of polar graph. There's always an A value after the equal sign. All right, so here we go. If n is greater than or equal to 2, so if that number is greater than or equal to 2, so it can be 2, 3, 4, or whatever, why can't it be 1? What kind of graph would this be if n was a 1? What would it be? A circle, right? Remember, theta, if you don't see a number in front of a variable, it means 1. That's 1 theta, right? It would be weird if we put a 1 there, but it's 1. That's why it says that. So n has got to be 2, 3, something else, okay? If n is odd, there will be that same number of petals, okay? We're not doing anything with symmetry. If n is even, you're going to have double that number. A, in both situations, is petal length. Now, looking at this first one, we have an n of 3. N is odd. And whenever n is odd, you'll have that many of petals. So we're going to have a graph that's going to have 3 petals. And when I say petals, I mean like looks like a flower, okay? A flower with 3 petals coming off of it. And the length of each of those petals will be 2. Why? Because of the 2. So that's how many circles will go out. Yeah. Right here. N is 3. Okay? So N tells you the number of petals. Yes, Jaden. Say it again. The number 3 is odd. Right? 1, 3, 5, 7, 9. No, that's 3 theta. Maybe I said something wrong. I don't know. Maybe I did. Okay, so let's just make sure we're clear. N is the number hanging out with theta. In this case, it's a 3. 3 is an odd number. If N is odd, that's the number of petals you have. Okay? The petal length is 2. And I'll explain that petal length better when we get to the graph. Now, how do we graph it? Well, here's my rose curve speech. Ready? If I really taught you all of the different types, rose curves are not as predictable as dimples, hearts, and circles, and loops. All the ones we did yesterday. Those were really simple to graph. If we knew a couple little things, we could quickly make the graph. Rose curves get kind of complicated at times. So I could spend, and if I kind of estimate, it would take me about 3 class periods to teach you all the tests for symmetry, all the ins and outs of these graphs until you got really, really comfortable with them. We don't have 3 days to waste, and to be quite honest with you, we don't need to know all the ins and outs. You get really deep into rose curves when you get to Calculus BC, if you get that far. I'll let your BC teacher really teach these in depth to you. For what we need to know for this class, just like yesterday I gave little nicknames and stuff, I'm going to give you the very basics of these graphs. And then I'll tell you what to do if I'm lying to you, which I don't think I am. Because remember, on the AP exam, there are no polar anything in the FRQs. So you never have to by hand make one of these. Any polar stuff that you get on the AP exam will be in the multiple choice section. And I will tell you by the end of the lesson, which we're almost there, believe it or not, by the end of the lesson, I will tell you what you would do if for some reason you get one of these in the non-calculator part of the AP exam, okay? Right now, though, we're not worrying about that. I'll come back to that in a minute. So how are we going to graph this? Well, you can usually assume that you can start these problems the same way we start all the others. I see cosine with a positive number. I'm going to go to the right with my first petal, first point, okay? How far to the right? That's your A value. That's how long your petals are. They're going to go out 2 circles. So I'm going to put a point here. And how you make your petal, guys, is probably better than me, but it just looks like a petal. And we're going to put it in our calculator right now so you'll see what it really looks like. Because we only got 1 petal. We need 2 more. And this is where, without a graphing calculator, it's a lot of work and would take a lot of time. We're going to go right to our calculator, go up to y equals. You don't need to clear your RAM every time, because if you clear your RAM, you're going to have to go change the mode. You can just keep typing over this. Right? Now I want 2 cosine, I'm going to clear it, 2 cosine 3 theta. Right? That's what I want to see. Hit graph. And for the rose curves, it really does make more sense to be in the zoom square. Because what you have to do right now is decide, and if you want to zoom in, that won't hurt anything, okay? And I'll show you that in a second. What you need to decide, so our first petal, we already drew it, right? You can see it over to the right. We have to decide where the other 2 are. This is where some students struggled. So listen, your other 2 petals, we have one in quadrant 2 and one in quadrant 3, are either hitting a denominator of 3, a 4, or a 6. Those are your choices, okay? So it's either hitting a denominator of 3, denominator of 4, denominator of 6. Denominator of 4 is going to be very obvious. It's going to hit right dead center in the middle of the quadrant. Your denominators of 3 are going to be really close to the y-axis, just like always. And your denominators of 6 are hitting really close to the x-axis. What do you guys say about those 2? Would that be a denominator of 3, 4, or 6, in your opinion? 3. They're closer to the y-axis. If it's hard for you to say, using your zoom in and then hit enter, even though it's cut off, don't let that bother you. You can see especially zoomed in, that we're as close to the y-axis as we can be. That means, and same with the bottom one, that means in my quadrant 2 and my quadrant 3, 2 and 3, I'm going to be hitting my denominators of 3. How far out am I going to go? 2. It's always the same. Always going to be whatever your A value is. So I would have a petal there and a petal there. And we'll see examples of closest to the x-axis and the middle in all of our examples today. And that's it. So you will make your graph using your graphing calculator. Let's do another one. So let me ask you, Jaden, if you don't mind. N is 5. Is that even or odd? Odd. Okay. So how many petals? That's right. Okay. So I think maybe I said the wrong thing.
No, I thought it said.
Oh, okay. That's a theta. Okay. I see. All right. All right. So we have 5 petals. Where the heck are they going to be? You can probably assume, and I'll tell you why I keep saying probably assume in a minute, that you're going to have a positive sign. You're going to have one of them going up, right? A value is 3. That tells you how far up we go. If you're not sure, use your graphing calculator. But again, I will tell you in a minute why I keep saying that. So I'm going to type in my new equation, 3 sine 5 theta graph. And I'm going to zoom back out again so I can see it a little bit better. All right, we were good with our first one. Now we have to see where the other 4 are. Look at quadrant 1 and quadrant 2. Would you call those denominator of 3, 4, or 6? 6. They're closest to the x-axis. Okay, so we're going to be at our denominators of 6 out 3 circles. So go out 3 circles at your denominator of 6. Draw your petals best you can. All right, and then look at your other 2. Would you say those are 6, 4, or 3? Which one? They're actually 3, okay? These are actually 3. Maybe hitting zoom in helps a little bit. You can see it's closer. In a minute, our next example will show you denominators of 4. The denominators of 4, you guys, are very, very clearly dead center. Those are not quite in the middle. Those are at your denominators of 3. That's my A value. A value, that's your petal length. Or in other words, how long it is, but what circle you go out to. Okay, so in the last one, Jocelyn, it was 2. We went out 2. A was 2 on this one. Does that make sense? Are you sure? Yeah. So A was 2, so I went out to 2. See, I'm at 2 in all of these. And then, yeah. Listen. Look, in this picture, you're not please guys, all your petals are not at the same denominator. It's okay. These 2 are at a denominator of 6. These are a denominator of 3. It's what the picture tells you to do. Next week, I will show you how to look at your table. And if you really want it, if you were really struggling, like I say it's 3, my neighbor says it's a 4, how can we fix this debate? It's in your table. It's just hidden in your table of values on your calculator. I'll show you next week how to do that. Let's do the even ones and we'll be done. Next page. First thing you should recognize is that this is a rose curve because it's got an N. Four is even. So anytime you have an even number for N, we double it. We're going to have 8 petals. My graph's going to look really ugly, I'm just warning you. All right, so again, you can assume cosine positive 3, we're going to have 1 point that's going to the right. How far to the right? That's your petal length, 3. So far, my assumptions have been right, but they won't always be, and I'll tell you on the next one why. So there is the graph. Do you guys see that we're going to have petals on all 4 parts of the axis, right? Jocelyn, how far out am I going to go? 3. Yep, here, here, and here. There's 4 of my 8. And then look at the other 4. What say you? Denominator 6, 4, or 3? Which one? 4. Those are dead center. Do you guys see how they're really exactly in the middle? Do you see that, Jocelyn? Right in the middle. Maybe zooming will help you. Whoops, I keep hitting that wrong one. Like you can see, it goes right to the middle in all those. It is the denominators of 4. So my denominator of 4 is there. I'm going to go out to denominator of 4. I'm going to go out to, there's 2 more. Awful. Here and right. Now listen, guys, I feel like you're very distracted today. Please focus on what I'm saying. On the last one, we're almost to the homework, but this is where I'm going to really help you with what could happen on the AP exam. If I kept going with my assumptions from everything else we've done with this in this section, I would probably assume I would go up, right? Positive sign, up 4. Don't do it though. I would have a petal up at 4, and then I would go to my calculator and find the rest of them. Look what happens on this one. So type it in, 4 sine 2 theta. Let me zoom out. I don't hit any of the axes. So that's why I keep saying I assume, I assume, I assume. You can't really assume on these, okay? Because there are exceptions to the rule. Where the other ones we learned yesterday, they're all very straightforward. There's no like, well, but sometimes this will happen. It's always the same. They're very easy to graph. That's what makes these very tricky. So on the AP exam, hopefully we get one that has a calculator, is in the calculator part, so you could graph it. But if not, what could you do? If you're taking the AP exam, you get to this question, and you are in the non-calculator section. Well, first of all, you're cursing me because you're like, she said that wouldn't happen. There's only 40 multiple choice questions. I'm fairly confident, highly confident that you're not going to get a rose curve in the 28 questions that are non-calculator. Okay, I don't think that's going to happen. Let's just pretend it did happen. What could you do? Plug and chug. You could make an XY chart just like we did here, or actually more like what we did here because you wouldn't have a calculator, and you pick some of your standard angles and start plugging in and figuring out what points are. Will that happen? Oh, sorry. Thank you. Will that happen? I don't think so, but always have a fallback method, and that's something I talked to you guys about yesterday. Why is it good to know this method? Because you can graph anything in the entire world if you know how to plug and chug points, okay? But I'm not going to take 3 days of teaching you all the symmetry tricks and everything for the very rare possibility that you get one of those questions, okay? So anyway, these are all going out to the middle, and our petal length is 4. So, sorry, let's just go back. This is even. There's 4 of them because you double when it's even. A is 4. So I'm going to go out to all of my denominators of 4 circles. Okay, just coincidence that it's all 4. Okay, so I'm going out. It's so hard to see. I think that's one of them. That's one. That's one. And that's one. So there are all of my petals. For the rose curve. So as I said, tomorrow when I introduce the project, what you're going to be doing is picking one of the types of graphs that I taught you yesterday or today, and making a picture out of it. I will show you tons of examples tomorrow of how people incorporated all these. You can start thinking circles. I get a lot of balls, baseballs, softballs, basketballs, soccer balls, flowers, hearts. Think of all the things you could do. You can see some of the things up there, and I'll show you a whole bunch more tomorrow. All right, let's go to the homework, page 182, and I'm going to do 3 with you. I'm going to do 8, 9, and 11 with you. So please write that down. So that whole assume thing, when I kept saying I will assume, let's pretend you're on the AP exam, you're on the non-calculator portion, you get one of these, you're cussing me out in your brain because she said I wouldn't have one of these. Non-calculator, what do? I have no time left. I have like 2 minutes left. I'm looking at the timer, I'm freaking out. That's when I would use my assumption. Okay, I have a positive cosine. I'm going to put one of the petals that way. Okay, there's only one example like that. I'm going to pick that as my answer. So sometimes you have to make educated guesses when you take these tests. That's what I mean when I say I assume. Okay? All right, I'm going to do 8, 9, and 11 with you. Please do them with me. Number 8, first thing you have to do, guys, is decide what type it is. The minute you see an N, you know that this is a rose curve, okay? Because it's the only ones that have that in there. So you say, okay, N, so A is 2, N is 3. 2 is my petal length, 3 is odd, so I'm going to have 3 petals, right? I can assume, there's that assumption, that I'm going to have one that's positive to the right 2. So if we're running out of time, no graphing calculator, that's the one I would pick. I would look at the differences in all of them. But we're allowed to use our graphing calculators for this. So let's put it in 2 cosine 3 theta and graph it. Okay, I was good with my assumption. Denominators of 3, 4, or 6, do you say, guys? 3, 4, or 6? Which one? 3. Closest to the y-axis, both of them. So I'm at my denominator of 3 here, and a denominator of 3 here. Always going out A circles. And that's it. What kind of graph is number 9? Circle. Right? The only difference between 8 and 9 is that N. There's no number in front of theta, except for 1, I guess. So this is a positive cosine, so that's to the right. There's only one number. And don't forget, we won't go past the pole. So all of our points are to the right of the pole. Circles are our favorite. They're the easiest. Hold off on 10 for a minute. I want to do number 11 with you because there's something in it that I've seen students make mistakes on quite a bit. So looking at number 11, the minute I see a plus or a minus, I go, oh, that's a heart, a loop, or a dimple. Okay? So you start going through your little steps, just like yesterday. So I have a positive cosine, so my first point is going to be to the right. How far? A plus B. What is A plus B going to be? 5. That's what I wanted to go over. Remember, you don't see a number in front of something. It means one of them. We would never write a 1 in front of that. We would never put a 1 in front of the theta. But that's what it is. It's 1 theta. This is 1 cosine. So that would be easy to make that mistake. So to the right 5. And then my axis width, that A value is 4. So on the other axis, I go 4, -4. There's 3 of the 4 points that I need. And I need 1 more point. So that comes from which type this is. Remember, we always do A over B. A over B, that's greater than 1. If it were equal to 1, it would be a heart. If it were less than 1, it would be a loop, L's, remember? If it's greater than 1, it's the other one. The one I don't have a cutesy way of remembering. dimple. Yep. And then we need one more number, and that's where to put that fourth point. So we just do 4 minus 1 or 1 minus 4. Doesn't matter which one. 4 minus 1 or 1 minus 4. We get 3 or negative 3, but we always think of it as positive. And it helps me to turn my paper. Remember, if it's a heart, it goes right in the middle of these two. If it's a loop, it would go down towards my first point. If it's a dimple, it's like the tallest graph. So I'm going to go up 3. And you make your strawberry, acorn, guitar, pick, peach, whatever you're thinking of it as. Oh my gosh, that's really good. I don't mean to brag, but that's a really good dimpled limousin. Sorry, I gotta compliment myself on that one. It's just so good. Okay, so this is it. I'll come check on you guys momentarily.